In this video, I am going to teach you the concept of node voltage and branch voltage. I have picked up this concept from the fundamental chapters of networks. These two terms, node voltage and branch voltage, you might have heard many times while dealing with this course. So to have a good understanding, I have taken one numerical problem, which is this one. And before we solve these problems, I'll be telling you what is its related concepts. And we'll make some observation at the end of these problems, which will be helpful for us to deal with certain numericals. If some information is there, if somebody changing the informations without involving into much detail, how to tell the answer directly. So let's start this one. So to explain this concept of branch voltage and node voltage, I have taken a network which is having three elements, element A, element B, element C. So this can be any element. It can be voltage source, current source, resistor, any electric elements. So there are three elements, right? And let's also assume like there are three elements are there, right? And if I ask you how many nodes are there in these networks, there are three nodes. What is the definition of node? Node is a junction where two or more elements are connected. So like that, if I count, this is a node, this is one node, this is one node, and this entire path has to consider a single node, right? So there are three nodes. And if I ask you what is the definition of branch, so branch is an elemental connection between two nodes. In other words, if one element is between two nodes, it is said to be branch. So if I ask myself, is it a branch? Yes, because this is between two nodes. Is it a branch? Yes, between two nodes. Is it a branch? Yes, again between these two nodes. So one thing is clear, we have three nodes and we have three branch A, branch B and branch C. And do remember, in any network, whenever you define any particular node voltage, that is always defined with respect to the ground node, or which is called as the reference node. Like in physics, when the value of Z, acceleration due to gravity, is by default taken as 9.8 meter per second square. Like the same way, in all the networks, whenever we talk regarding any particular node voltage, that is always commented with respect to a 0 volt node or a ground node or the reference node. And it's a personal choice where you'll be taking that particular reference node. It depends, it's your choice. I can take it here, I can take it here, I can take it here. But very generally, in most of the books and in many cases you might have seen, by default, in almost all cases, they used to take the ground as this one, right? But that did not be, you are not, compulsory, like you have to take that is node. You can take any one. So that is what the main concept is. Like we'll see if this ground is changing to somewhere else, what are the things that will be getting changed in these networks? That we'll see with respect to this problem. Okay, so this is the ground node I'm taking. So I'm making this is ground. And if I'm saying this node voltage is VA, it means this point potential with respect to this is VA. And if I say this is VB, so this point potential with respect to ground is VB. Okay. So in any networks, you can define any node voltages, but by default, those are referred with respect to the ground. If somebody is saying this is VB, then it should come in mind. So this is the VB with respect to this one. So there could be many other nodes, but when you talk regarding a node voltage, that has to with respect to ground. So this is the node voltage. Now what is the branch voltage? So remember, branch voltage is the difference between two nodes across which that branch is connected. For example, if I ask you what is this branch voltage, so you can say this branch voltage is difference of the node voltages between which it is connected. Someone can say it is VA minus VB, or someone can say it is VB minus VA. Similarly, if I ask you what is this branch voltage, so VA minus 0, or somebody can say 0 minus VA. So similarly here, VB minus 0, or 0 minus VB, whatever, right? So what kind of notation we use to write this branch voltage is, so there are two ways. Suppose for example, if I'm writing this is plus and this is minus, the voltage we are supposed to write here is plus side voltage minus minus side voltage. So plus side is connected to VA, minus side is connected to ground at 0 volts. So this is VA. However, if I'm saying this is plus and this is minus, then if I ask you what is this particular voltage, plus side voltage is 0, minus side voltage is VB, right? So in this case, your answer is 0 minus VB, that is minus VB. If I ask you what for this, then I have again two ways. Suppose for example, if I'm writing this is plus and this is minus, then here I should write this minus this. So this is your BA minus BB. Or somebody can say, no, I want this side plus, I want this side minus. Then plus side voltage minus minus side voltage. So this is VB minus VA, right? So there's nothing wrong. You can take either this or this. It's again your choice, right? So sometime it happens in network analysis that a node voltage happens to be equals to the branch voltage, right? For example, this one, if I see the node voltage is VA, branch voltage is VA, right? But it's not happening in this case. It is minus VB. This is VB, this is minus. There is a sign mismatch. So very frequently, in general, in many network analysis, the bottom line is taken as ground. And then in that cases, if it happens, if somebody is taking the bottom part itself is negative and this positive, it happens that node voltage equals to branch voltage, because when we are doing this minus this, so that minus, the second minus is becoming 0, so we get branch voltage equals to node voltage. But that is in general not necessarily to be true. So you should understand what we are saying. So I hope this concept is clear. Keeping this concept in mind, let us try to solve this problem. So what I have given is, this is a network I have given where you can see the voltage polarity of elements are given, right, with the corresponding value, like 1 volt, 3, 2, 6, 4 with the corresponding polarity is being given. The question is, obtain the node voltages of node A, node B, node C and node D if A is ground, if B is ground, if C is ground, if D is ground. And also obtain the value of VAC, VDB, VCB, etc. in each of the cases. So basically the problem is, what I can say is, if A is ground, what is the answer of VA, VB, VC, VD? If B is ground, what is the corresponding answers? And similarly for C and D. Now to have a comparison and to make a conclusion or observation, whatever you can say, I have drawn this particular table here, right? And in this one, what I'll be filling up with in this column, if A is ground, what are this corresponding value of these voltages? So in this column, I'll be filling, if B is ground, what are this voltage, and so on and so forth. So what I'm doing is, let's start with from the last one. Like, many of you like the bottom part should be ground. So I'm taking the D node as the ground. So this is the ground, right? And please do remember, in any network, you cannot have 10 number of grounds, right? So in any networks, the ground or reference node is always unique. And that is your personal choice which node you can take its ground. So like that, if somebody thinks like we can have many number of grounds, then every node voltage you can make it ground and you can say every voltage is 0. So that is complete meaningless. So let's start with the D is ground. So I have highlighted this. What is the meaning of D is ground? The meaning of D is ground is the potential of node D, this is 0 volts. So this is being 0. So with respect to this, I want to calculate what is VA, what is VB, what is VC, right? Now see. So if I want to calculate VA, you see how do you calculate? So this is plus, this is minus, right? So what minus what is 1? So VA minus this one, that is 0, is 1. So VA minus 0 is 1. So obviously VA equals to 1 volts. Now how do you calculate VB? So to calculate VB, I have two ways. Because I know VA, I can say VA minus VB equals to 3. I can make use of VA and I can get VB. Otherwise, if I refer this one, what minus what is 2? So this side is plus, this side is minus. So 0 minus VB equals to T, right? 0 minus VB equals to 2, minus VB equal to 2, and VB equals to minus 2. So VB is I am getting as minus 2 volts. Now how do you get VC? To get VC, I have again two ways. Either I can make use of this 6 volts because I know VB, or I can make use of this, right? So what minus what is 4? So this minus this, that is VC minus 0 is 4. So VC equals to 4. So I got VA, VB, VC and VD. And one more thing. So whenever I'm writing it is VA minus VB, right? For a compact notations, instead of writing like VA minus VB, we used to write this by VAB, right? So if somebody is saying it is VXY, so you should think this is actually VX minus VY, it is written as VXY. If somebody is saying VYX, that is, then in this case it will be VY minus VX, right? So I can write this as VAB with this polarity, right? So this will tell it is VA minus VB, or I can write this is VBA. When I write VBA, it is VB minus VA, right? So similarly, if somebody is saying what is VAC, it means I need VA minus VC. So 1 minus 4, that is minus 3. What is VDB? VD minus VB. 0 minus minus 2, 0 plus 2 is 2. VCB, VC minus VB. So 4 minus of minus 2, that is 6. Or you can take, any other difference of this, you can take it for observation point of view. So I got this answer, right? So I hope there is no doubt, nothing else. So the intention of this particular problem is not to get this value, but to have the observations. Now the way I have calculated for D, now let's make the calculation for C, and then without referring this network itself, we can directly tell what are the answers with respect to A and B, right? So as I said, in a network you cannot have n number of grounds, right? So if I want C to be ground, then D should not be ground. So I'm taking this is my ground now. If this is now ground, now let us recalculate everything again. What is VA, VB, VC and VD? Well, so I can make use of this and this to get VB and VD, right? So if this is 6, what minus what is 6? So plus side minus minus side. Plus side is 0, minus side is this one. So 0 minus VB is equals to 6. So VB is equals to minus 6. And by the way, if I'm saying VC is my ground, so VC is equals to 0. VC is equals to 0, right? And of course this is, I hope this is clear. Now coming to VD, what minus what is 4? So plus side voltage 0 minus VD is 4. So VD is equals to minus 4. So I got the answer of VD is minus 4. Now how do I get VA? To calculate VA, I have two ways. Either I can make use of this and this node voltage, or I can make use of this and this node voltage. Because I already got VB and VD, I can make use of this. So if I'm thinking of this one, so what I can say, VA minus VD is equals to 1. I need the value of VA. So VA is equals to 1 plus VD. So this is 1 plus VD I got at minus 4, right? So this is coming as minus 3 volts. So this is coming as minus 3 volts. And if I ask you what is VAC, minus 3 minus 0 is minus 3. What is VDB? So VD minus VB, minus 4 minus of minus 6 minus 6 is 2. And VCB 0 minus minus 6 is coming as 6. This is the answer. Now before we fill up this two column, now let's have the observations or comparisons with respect to this column and this column. Now you see, when I have taken D as the ground, so D node was 0 volts, right? Now when I take C, and D node was 0 volts and C node was 4 volt, right? Now once I'm making C as ground, what is happening is, the voltage which was 4, that becoming 0. So here there is a net decrement of 4, right? So you notice carefully, all the individual node voltages are also decremented by the same amount. Because this is 4 minus 4 is 0, you see this is minus 2 minus 4 is minus 6. 1 minus 4 is minus 3 and 0 minus 4 is minus 4. So what it says, if one of the node voltage is changed by some amount, rest of the node voltages are also getting changed by the same amount. But however, if you see the last three rows, the VAC, VDB, VCB, they are remaining same. They are not getting changed. So what is the concept behind this? Why it is coming same is, the logic is this. See, when somebody is saying this is 4 volt, it means this minus this is 4. So what is the absolute value of this? What is the absolute value of this? That's no matter to us. It can be 104, it can be 100. It can be 20, this can be 16. It can be 40, it can be anything. It can be any individual voltage, but what we want is the difference of them should be 4. Now it makes sense. Now you think once, if earlier it was something else, right? And if this is changing to something else, then what should happen to this one so that this difference will be maintained same? For example, I'm saying, let's say this one if I'm saying, if earlier it was X and this was Y, right? With respect to this X minus Y, let's say it is coming 1. Now due to some reason, if I'm saying this is becoming X minus 10, now what should happen to this so that again this will be 1? Because this is not changing, right? This has to be 1. So if this is decremented by 10 or incremented by 10, whatever, the same change should also be reflected here so that the difference of them should be maintained same. So it of course makes sense, if one of the node voltage is getting changed by some amount, all the other node voltage has to also getting changed by same amount so that the difference of them or the branch voltage will be maintained constant. So this is no surprise why they are remaining constant and why they are getting changed by the same amount. And why these are being remaining constants? Because if I am saying each of the node voltages are changed by same amount, obviously that difference will be cancelled out, right? So you'll have the same thing. Now, if you understood this concept, now we can easily fill up this column and this column. What is the meaning of B is ground? The meaning of B is ground is VB is 0, right? VB is 0. When I say VB is 0, you see with respect to this column, there is 6 increment, right? So if this is 6 increment, so this will be minus 3 plus 6 is equals to 3 volts. This will be 0 plus 6 is 6 volts. This is minus 4 plus 6 is 2 volts. However, if I ask you what are this, so without any doubt, you can again copy the same value. Now, you should not have any doubt like why I am doing with respect to this column. If some of you like with respect to this column also, you can make it. So once you are making B is ground, so which was minus 2, that becoming 0. So there is a net increment of 2 with respect to this one. So that's why 1 plus 2 is 3, 4 plus 2 is 6, 0 plus 2 is 2, and they are remaining same. And if I make A is ground, so VA is 0 now. If VA is 0, I can, let's say if I am referring this one, so minus 3 becoming 0. So that is plus 3, right? So this is minus 3, minus 6 plus 3, minus 3. This is plus 3, minus 4 plus 3 is minus 1. And obviously, they will be again remaining same, minus 3, 2, and 6. So this is what the corresponding answer is, right? So we obtain all the voltage when A is ground, when B is ground, C and D is ground. And these are the corresponding value of VAC, VDB, VCB, each of these cases, right? Now, the observation that what someone should make is, like if somebody is asking, so we have answered this. So if somebody is asking, suppose this is what the network is given, nothing else is given, okay? So I have removed the ground also, you see. So if somebody is saying, obtain the value of, suppose somebody is saying, obtain the value of VA, VB, VC and VD, right? Then you cannot say what is the answer of VA, VB, VC or VD. Suppose somebody is asking VB, I can give him 4 answers because VB can have this 4 value, right? So VB can be minus 3, it can be 0, it can be minus 6, it can be minus 2. Similarly, each of these nodes having 4 different values. So the conclusion is very simple. In a particular network, the node voltage cannot be commented uniquely unless until the ground is not given. If somebody is asking this kind of questions, either you give him all the answers or you ask which ground you need, with respect to what ground you need the answers. So without that information, we cannot tell what the answer uniquely. In fact, in many GATE exams, in many previous year GATE papers, you see there are so many questions, even that ground node was not given and they're asking some node voltage. But by default, everybody, it's a tendency, like we are taking this base as ground and we are doing this. But strictly speaking, if somebody changes this ground to something else, the answer will not be same, right? So I hope this is clear. So to comment any individual node voltage, right, we need the ground information, compulsorily we need it. However, if you want to comment difference of 2 node voltages or any branch voltage, then that information is not much essential, because in that case, you can take any of your node as ground and you can do the analysis. So the answer will not change, right? But in this case, it will be changed. So what is the application of this? Where this can be used? Now let me show you a scenario. See, I hope most of you might be knowing the concept of nodal analysis, right? So let's say I have some networks, I am just taking something like this, just for understanding purpose. I have taken like this. So let's say this is my node voltage VA, this is my node voltage VB, this is my node voltage VC, this is my node voltage VD, this is, let's call it is B1, R1, R2, V2, I1, R3, R4, V3, R5 and I2. So something like randomly I have taken. Now suppose somebody is saying obtain the value of VA, VB, VC. So there are of course many ways you can go off, think of mesh analysis, superpositions, various other way. But nodal analysis, let's say if you have done it, so most of you might be preferring to solve this by nodal analysis. Let us say you have taken this point as the ground for your comfort purpose. And then if I take this point is ground, so obviously VD equal to 0. Now let's say the component value, I mean all resistance and battery and currents are given in such a way that VA answer I'm getting it is 9 volts, VB answer I'm getting it is minus 1 volts, and VC I'm getting it as, let's say 16 volts I'm getting, for examples. So how do you get it? You have to write the equations here like BA minus B1 by R1 plus I2 plus BY plus B2 minus BY R2 like this. 3 equations you'll get. One be here, one be here, one be here. Then by solving them, by rearranging, then by solving, let's say this is the answer you got, right? Now somebody is saying, no, I'm changing this VD which was ground. I'm changing this ground point from here to, let's say somebody is saying, I want, let's say this is the ground point now, or any other one. Now what you have to do? Suppose you don't know this concept. Now you have to rewrite all the 3 equations again, and again you have to calculate. Again rearranging, again solving. So obviously it's a tedious and time consuming process. However, if you understood this concept, now directly I can tell what are the answers. So VC, if somebody asks, so this is becoming 0, right? So there is a net decrement of 16. So this voltage will be minus 16. This will be minus 1 minus 16 is minus 17. And this will be 9 minus 16 is minus 7 volts. So not only this, again if somebody is saying, no, I want, this is my ground, right? Again you can do the calculations. So in this case, what is happening? VA is 0. So if you see with respect to this one, so that is plus 7. So minus 17 plus 7 is minus 10. This is plus 7 and this is minus 9 volts. And so on and so forth. So this is the applications. So if this is what the original problem given, some of students, they don't feel comfortable to write the nodal equation from scratch from this point onwards. What they do is, they always like, because they're habituated, they always like to nodal equation with respect to by taking this as the ground. And if this is what is happening, then to make use, by making use of this concept, you can write the equation with respect to this, and then again by making use of this concept, you can calculate the node voltages, whichever the node you are supposed to take as the ground, right? So the conclusion in this is, node voltage cannot be commented uniquely unless until the ground information is not given. But to comment the branch voltage or to calculate difference of any two node voltage, the ground node information is not essential, because you can take any node as the reference. And secondly, if we know the solution, if you know all the node voltage with respect to one particular ground, then if somebody is changing that ground to somewhere else in that networks, then we don't have to recalculate the things again from the scratch. By making use of this concept, directly you can tell what are the corresponding value, right? Hope you like this video. Thank you for watching. Thank you.